Okay, so this is where we left off, right? Somebody fix me if I'm wrong on this one. Well, let's see if I have some more of them. Here are some. So this one, all we really got to cover is this one section today. Is 4.1 is what we're going to cover. And basically we're back into some graphing. And I don't think these things are anywhere nearly as hard as what you have done in the past. So this should be pretty simple as long as you're pretty good at solving the equations, and as long as you're good at solving equations, you should be fine with this section. But I do want to note that these notes at the top are really going to be helpful to you as far as how you're going to work these problems once you get into MyLab Math, and what you need to remember to work the problems when you get to the test, okay? So anyway, it says when we have what we call a series or a system, and that's a term you kind of want to get familiar with, a system of linear equations, it really has equations that may or may not intersect with each other. In other words, these are straight lines, right? And a straight line is, if it's parallel to another line, it's never, ever, ever going to touch. But if it's not parallel, if it's perpendicular, or if it's just another line with a different slope, eventually it is going to touch. They're going to cross each other, okay? Now, where they cross is the solution to the system of linear equations. And it is one point, because these are straight lines, right? They're not curved lines that are going to come back and cross the same line more than once. So this is a solution is going to be 1 point. It's going to look like an ordered pair, an x and a y pair, okay? So here's the three different types of systems we have, the solutions that they have, and what you would call these, all right? In other words, if you have something that's consistent, and we call it a system that would be a consistent system of linear equations, it would be one solution. And basically what it says is these lines cross at 1 point, okay? Easy to understand. Inconsistent, well, I always just call that when it has no solution. Basically parallel lines. They have to be parallel lines. If they're not going to touch, there's no way they can be anything but parallel lines. Does that make sense to you? Okay, so really, if you can find two lines and they have the same slope, you know that they are inconsistent or have no solution, right? You don't even have to do the steps that we're about to do to go through it. And the other one is, a dependent. Okay, well, you can't have one line that lays on top of another line, and basically it's the same line. How many solutions do we have? Well, it's an infinite number, because every single point on that line, or both those lines, is a solution. And this one we're not really going to work with too much, but we are going to work with the consistent and the inconsistent, and you're going to be looking for the fact that they have one solution or no solution. Okay? Basically, that's what you're going to be asked. Okay, so how do you do it? Well, there's one way you can do it that's called graphing it. So you could basically graph these lines. We could graph these two lines. We could have the coordinate system, and we could graph these two lines, and wherever they cross, that would be our solution. Well, how do you graph x plus y is equal to -1? And what I would do is take this thing and make a little chart. We have x and y coordinates, right? So if x is 0, for example, I would plug in 0 for x, and what I get is y is equal to a -1. I really don't even have to write that one down, do I? Isn't that pretty simple? Because if x up here was 0, then that part would go away, and we'd say y is equal to -1. The same thing happens if we say y is equal to 0, doesn't it? What's x? -1. Now, if I have 2 points, then I have a line, a straight line. But sometimes I make mistakes. So I like to have a third point just to check it out, all right? So we pick a value for either x or y. Now, this is exactly what you're thinking. We've done this before. You're right. We did this before, okay? So we pick a value for either x or y. So let's say I say x is equal to, pick something. Okay, x is 2. So if I have 2 plus y equals -1, well, then I'm going to subtract 2 from both sides, right? And I'm going to end up with y is equal to a -3. Now, when I graph it, that third point is sort of my checkpoint. If it's not straight in a straight line with the other two, then I've done something wrong. So I'm going to go 0, -1. Well, there's the first point, isn't it? And then I'm going to go -1 and 0. There's the second point. Well, those are kind of close together. So where's the third point? It would be +2, -3. Right here. Yeah, sorry. Oh, shoot. Okay, better. Thank you for telling me. Okay, so now I've got this straight line, and it always helps to have some sort of straight edge to draw these with. I don't do this well, but I'm going to draw it. Okay, here it is. All right, it's as straight as I can get. Okay, straight line, right? Actually, that's not too bad. All right, so next one. This one's graphed. Let's do the next one. If I say x minus 2y is equal to 14, and I'm going to pick 0 for y. That's easy, isn't it? Because then this term disappears completely. And what do I have? Well, I have x is equal to 14, don't I? Well, that's not even on my graph over here. I really don't like that point. Do you? Let's try the other one. Let's try what happens if if x is 0. Well, that was going to take a little more work. I'm going to say 0 minus 2y is equal to 14. Well, 0 is not really going to do anything for me, but I do have to divide these both sides by -2, and y is going to equal a -7. Now, I really need a third point, don't I? Because this 14,0 is going to be impossible for me to graph on this particular chart. So let's take something a little bit. I'm going to pick x of 4. I just am. Okay, I don't know if this is going to work out for me or not. But I'm going to say if x is 4, then I have 4 minus 2y equals 14, right? Well, -2y is equal to, what do I have to do? I had to subtract 4 from this side and subtract 4 from this side, right? That's going to equal 10. Divide both sides by a -2. And I get y is equal to a -5. Well, that at least is on the chart, isn't it? And then I plot those 3 points. I've got 14, 0, not going to be able to plot that one. But 0, -7 is down here, isn't it? And then I've got the other one, 4, -5. Where's 4, -5? And 4, -5, look at, that just so happened. I really didn't plan that. Look at where it is. It's on the other line, isn't it? Okay, what's the solution to this set of linear equations, this system? Well, the solution is 4, -5. It's what they have in common. There's only one point they have in common. And that will happen anytime you have a line that is not parallel to another line, okay? And let's forget the fact that we could have lines that overlay each other, because that makes, you don't really have too much work to do there. They're the same line, aren't they? Are you good with that one? Yes. Do I have another? You want a copy of it? It's up here. I do. You're welcome. All right, let's go to page 20. All right, in this one, to solve a system of linear equations by substitution. Because as you can imagine, guys, graphing them gets really difficult, doesn't it? And then you've got to have the graph, and you've got to have an accurate drawing of the line, and there's no way to really do it outside of having a computer do it. So we have a mathematical solution to it, and it's called this first one's called substitution. Okay, so what are we going to do? Well, we're going to, number one, solve one of the equations for one of the variables. And it doesn't matter which equation you choose, and you're going to solve it. It doesn't matter which variable you choose to solve it from. Then you're going to take that solution, and you're going to plug it into the other equation, okay, the second equation. And then you're going to be able to see what the exact points are that you're going to discover. And I'm going to go through this because it's easier to show you than it is to explain it. But do keep note of these, where these notes are, all right? These steps are, because after you've finished this is a good idea to go back through and make sure you understand the steps and that you don't skip a step when you're doing the work, okay? So first, we're going to solve for one of them. It doesn't matter which one, but look, this one is already solved for y, isn't it? This one is y is equal to 6x. So step one is done for me in this one. One of the equations is solved for one of the variables, Are you good with that? I mean, it doesn't matter if it was solved for y or x. So I now can take 6x and I can plug it into the other equation, for y. Can't talk and teach at the same time. It's a hazard. Okay? I'm going to take 6x, I'm going to plug it in for y because y is equal to 6x. So I have x plus 6x is equal to 21. Well, that's 7x is equal to 21. I divide both sides by 7, and I get x is equal to 3, right? Good with that? So now I need to know, okay, I got the x part of my coordinate, but I don't know what y is. I do know y is equal to 6x. What if I take that 3 for x and I plug it into that equation, and I say y is equal to 6 times 3? Y would equal to 18, wouldn't it? So what's the point I've got? 318. Now, did it matter which equation I plugged it into? Well, not at all. What if I plug this 3 back in here? Take it up here. What if I said 3 plus y is equal to 21, right? Well, I'm going to subtract 3 from both sides, and I'm going to get y is equal to 18. You see? Doesn't matter which one you plug it into. Once you have solved for one of the variables, you plug it into the other equation, and then, or into any equation, either equation, and you solve for the variable that you don't know. And you have the x and y coordinate, and that's the substitution. How are you with that? It's not hard, is it? It's just solving. You know, if you're okay with solving the equations, you should be okay with this. Let's do another one. I mean, you could pick anyone you want to you could pick anyone to solve for. I'm going to say, this looks easier to solve for y to me because I've got a single y, you know? I mean, it's a negative y, but I'm going to take this one, and I'm going to say I need to solve for one of the variables. I'll choose you because you look easy. I have to subtract 7x from both sides, right? So I have over here, this goes away, but I have negative y is equal to a negative 7x plus 9. And then what am I going to do to finish this up? Yeah, divide each term by negative 1. In essence, all you're doing is changing the signs, right? I'm going to divide you by negative 1. I'm going to divide you by negative 1. I'm going to divide you by negative 1. I'll have a positive y is equal to a positive 7x, and that's going to be a negative 9. Okay, so we're good at that one. Now what do? Well, we solved this equation. We're going to plug it into the other equation. Now it does matter where you plug it in, okay? After you have solved for one of the variables the first time, we're going to plug it in, look, right here to the second one. So what we have is 6x plus 4 times, and put it in parentheses because it's got 2 terms to it, right? 7x minus 9, and that's all equal to a negative 36, right? Well, distribute multiplication first. I say 4 times 7x, and I say 4 times negative 9. Now, we can combine these two terms, can't we? And I can say 6x plus 28, well, that's going to give me 34x, isn't it? And over here, I'm going to add 36, and then I add 36, right? Well, this is going to be a 0. And over here, it's going to be a 0. So this is equal to 0, isn't it? You see it? Make sure you do. I mean, it's just, I'm skipping a few steps, or I'm shortening them because you're advanced algebra students now. So now I'm going to divide by 34. And what you have to ask yourself is it okay to say 0 divided by a number? Or is that something we can't do? Is it okay to say 0 divided by a number? I always think about it like this. Okay. That's okay. If it had 0 on the bottom, let me just go over this real quick. If it was this, that would be no. That's undefined. Okay, and one of my kids told me that's how they remembered it, and I've always just kind of tried to pass that on because it's an easy way. Okay, so it isn't that, but it is okay. Therefore, the answer is 0. All right? So now what do? Well, now we can take this x of 0, we can plug it into either equation. Well, I'm up here looking at my equations, and this one still looks easier, so I'm going to say 7 times 0 minus y equals 9. Well, that's 0, isn't it? So I've really got minus y is equal to 9. Once again, divide everything by a negative 1, and I have y is equal to a negative 9. Okay? Now, I didn't check the solution in the last one, but checking the solution is the next part of your, see if you got it right, okay? What point do I have here? Well, the x variable is 0, the x coordinate, and the y coordinate is negative 9. Plug it into one of these equations. If I said 7 times 0 minus a negative 9, would that equal 9? Well, 7 times 0 is just 0. This is plus 9, right? And that's my check. It works. You can plug it in the other equation and it works. If you check, if it says to check your solution, that's what you're supposed to do. Take your solution and plug it into one of the equations. Okay? Are you good with this one? Okay, go back up to number 1 and check your solution. What solution do we have? 318. Plug it into one of those equations and see if it checks. Practice, just for practice. The first one's pretty easy to plug it into, isn't it? What do? You say 3 plus 18 equals 21. Well, that's the check, isn't it? The other one's just as easy. Okay, that's the substitution method. We're going to solve for one of the variables. We're going to plug our solution into the other equation, and we're going to find the second variable, and then we're going to plug it back into one of the equations to find the other variable, the first variable, okay? I mean, it's sort of like back and forth. The first time it does matter which equation you put it in. The second time it does not, if that helps you. Okay? All right, let's talk about another method. This is the addition method. And I think you're going to find it, instead of calling the addition method, you're going to find it called the elimination method more than that, okay? And it says we have to write the equations under each other so that like terms are aligned, okay? So one of the equations might have to be rearranged, all right? And then you're going to eliminate one of the variables. Now, you're going to be adding these equations. So to eliminate one of the variables, you need it to be the exact opposite of the equation above it. In other words, if you have 3x and you want to eliminate it, you need a negative 3x so that when you add them together, you get 0. Does that make sense? All right, so, and then we'll go through solving it and substituting it just pretty much like we did before. But we have some decisions to make about these equations. Which one are we going to use for what? This one has the x terms and the y terms aligned, doesn't it? And the numeric term is over here on the end. I have 4x and x. I have y and negative 3y. I have to decide what's going to help me cancel out one of those variables, because you can use either one. I could come down here and I could say, well, I want to cancel out the x variable. I could say, okay, well, I need a negative 4x in this one, and I could change it. I could multiply everything through by negative 4. But I could also say, well, I have a negative 3y. I have a positive y. What if I just multiplied everything through by a positive 3? It would cancel. Make a decision. Either way works, okay? Make it easy math. I think, hang on. I think that multiplying through by a positive 3 might be my answer here. So I'm going to do that. I'm going to say 3 times this side, which is 4x plus y, is equal to 10 times 3. And I'm writing it down just so you can see what I'm doing. I'm multiplying both sides of the equation by the same number. Therefore, I haven't really changed the value of anything. I've just changed the terms of it, okay? So 4 times 3x gives me 12x. I'm sorry, yeah, 3 times 4x. 3 times y gives me 3y. And that's going to equal 30. Okay, now let's put that other equation underneath it. I've got x minus 3y equals 9, right? Now, let's take these two equations, and you could draw a line if you want to show what you're doing here, okay? Let's take these two equations and let's add them. When I add 12x and x, I get 13x. These two are going to cancel. Well, that was the whole purpose of this, right? So I have 13x is equal to 39. I'm going to divide both sides by 13, and I'll have x is equal to 3. Okay? All right, good enough? Now what do I do? Well, let's take this x is equal to 3, and let's plug it in to the other equation, right? Let's see, 4x, 4 times 3 plus y is now equal to 10. So what do I have? I have 12 plus y. Can you see what I'm doing? Is equal to 10. I think you could have plugged it into either equation, actually. And this is going to equal to, what am I trying? I'm doing a minus 12 over here and a minus 12 over here is equal to a negative 2, isn't it? I have the x and I have the y. Don't I? So I'm going to write the point. The point that I have is 3, negative 2. And I'm going to check it by plugging that into one of these other equations. I don't care which one. I'll just do the first one. I'm going to say 4 times 3 minus 2 is equal to 10. Is that true? Well, 4 times 3 is 12. 12 minus 2 is equal to 10. That is true, right? So my solution worked. I could plug it into the other equation too. It didn't matter. Which method do you like? The elimination method, or do you like the substitution method? It all depends on the problem. You know, it depends on what you see when you first look at the problem. And they're going to ask you to work it both ways. And on your test, you're going to be asked to work it both ways, okay? Let's try this next one. I've got x minus 3y is equal to 17, and 2x minus 6y is equal to 17. I can't remember which one I tried, but I think I took the first equation again, and I got it to where it was a, what did I cancel out? A negative 2x, okay? I want this one to have a negative 2x. This one has a positive 2x. That way I can cancel them. So I said negative 2 times x minus 3y is equal to 17 times negative 2, right? If I'm going to multiply one side by negative 2, I've got to multiply the other side. So let's distribute. Negative 2x plus 6y is equal to negative 34, right? Now, I'm done with doing that. I'm going to come down here and put the other equation under it. 2x minus 6y equals 17. Let me kind of draw my line here because I don't want to get confused. These are the two equations that I'm adding. When I add these two terms, they disappear. Uh-oh. When I add these two terms, they also disappear, don't they? What do I have over here? Well, 0. And I add these two terms, I get a negative 17. Ask yourself, is 0 ever equal to a negative 17? No. There is no solution to this set of linear equations. In other words, these must be parallel lines. Okay, let's go on that premise. These must be parallel lines. Can you tell me what the slope is? You should be able to do this from last time. That's why we're going to do it. It's sort of a refresher. Yeah.
Is it negative 2x?
Well, the slope, you're going to have to get it into y is equal to mx plus b format, slope-intercept format, to tell what the slope is, right, of one of the lines. So you take both of them, get them into y is equal to mxb format, and then tell me the slope, okay? Because in answer to your question, the slope can never have a variable as part of it. It's just a number, okay? Yes, get rid of the x, okay? It's just 1/3, yeah. Did you get it? I'm going to take this first one, and I'm going to get it into y is equal to mx plus b, right? You see what I did? I just subtracted x from both sides, didn't I? And now I have to divide everything by -3. Well, this comes out to be y is equal to, and what this is a positive x over 3, which I'm going to write separately from my variable because that's my slope, right? And I don't care about this y-intercept. Doesn't matter that it's a confusing looking fraction. Just leave it, right? We're not even asked about it. What is the slope of this line? Somebody, what is it? 1/3. Is that the slope of the other line as well? Did you check it? Let's do it. I need this y to be isolated. I'll subtract 2x from both sides, right? -6y is equal to a -2x plus 17. And then I have to divide by -6. This is -6, this is -6, this is -6, isn't it? Did I write that one down right? Okay. So what have I got over here? Well, I've got y is equal to, and that's a positive 2/6. What's a positive 2/6? 1/3, right? And I'm going to go over here, go over here and say -17/6, which really doesn't matter. But this, what we're trying to say here is, are the slopes the same? We'll reduce the fraction. They're parallel lines, aren't they? There will be no solution to parallel lines, right? Okay? That's just a little bit of practice in doing something that we did the other day. Okay? You're good. You can figure it out by using that elimination method, though. Let's do a couple more. I think I've just got 2 more for elimination method for you to do, okay? To do them and check them. Can you do these on your own? Going back to the steps that we did, see what you can do, okay? Did you get, when you solved it, that 0 was equal to 0 here? Or did you get the same number was equal to a certain number? Anybody?
My first equations cancel out.
So everything on one side went to nothing and everything on the other side went to nothing. So it's basically what you're saying is 0 equals 0, right? If everything cancels out on one side, you got 0. If everything cancels out on both sides, you got 0 equals 0. So what is it trying to tell us? Well, basically, 0 is equal to 0. That's a true statement, isn't it? Basically, what it's trying to tell you is that these look like they might be the same line. Now, I kind of want to prove this. I've got 9x plus y is equal to 8, don't I? And if I put that in slope-intercept format, because that's where it's easy to compare, I'm going to have y is equal to a negative 9x plus 8. There's my slope-intercept equation of line number 1, right? Well, let's do the same for number 2. First, for number 2, I'm going to say, well, 2y is equal to, let's get it in the right order, negative 18x plus 6. Now, is there any, 16. Is there any way that this one could be conformed or converted to that one? Any mathematical thing you could see that would change this equation to look exactly like that one? What could we do to both sides of this equation? Yeah, factor out the 2. What he's saying really is, let's divide everything by 2. We can divide everything by the same number, right? And we haven't changed the value at all. We're just writing it in a new form. What's this? Well, that comes out to be y. This is a negative 9x. This is an 8. Well, guys, these are the same equation, written in different terms. In other words, these lines lay on top of each other, don't they? They overlap each other. They lay on top of each other. Making a note over to myself, so ignore me a minute. Okay, how many solutions do they have? Infinite number. Every single point on those lines is a solution. Okay, do you understand the difference? Okay, see what you can do with number 4. I'm just going to tell you if you need a hint, okay? I'm going to work up here, but I'm going to start by converting the first equation so that it cancels the y's, okay? That's where I'm going to go, if that helps you. Now, once I converted, I'm going to lay them on top of each, I'm going to lay them under, I'm going to match them up, and I'm going to add these two equations. So I've got 8x plus y plus 1x, right? 9x. The y's cancel, and 9x is equal to 18. Well, that's convenient. When I divide by 9, x is equal to 2. Now I get to plug that 2 into either equation, don't I? Go ahead and finish this. I'm going to, excuse me for just a second. Okay, so I came up with x is equal to 2, and then I'm going to plug it into either one. I'm hoping you guys have gotten to that point by now. I'll just plug it in up here to the same equation. Well, actually, it's easier with here. So I say 2 minus 2y is equal to 6, and if I subtract 2 from this side, subtract 2 from this side, then these go away, of course, and I have negative 2y is equal to 4. Divide by a negative 2, right? And y is equal to a negative 2. Is that what you got? So the point came out to be 2, negative 2. Okay, so you plug it back into one of these equations. Doesn't really matter, does it? What if we did the second one? We'll say, this is my check. I'm going to say 2 minus 2 times a negative 2 is equal to 6, and that would be 2 plus 4 is equal to 6, and at that point I can say, yep, it worked. All right, how do you feel about that? Okay? Yes? Okay, if you are solving equations is okay for you, then this should be a piece of cake. You just have to get the different steps in mind. I'm going to say this one more time. Go back over these steps for the elimination method and make sure you understand what they're saying, okay? Where they're saying sometimes which equation can you use, right? And go back over the steps for this addition method or substitution method too. All right, and then you've got some work to do, and we have a review next week, and then we have a test. I'm going to be here. We're out early, but I'll be here if you have any questions, okay, for a while. Good?